Welcome, everybody. This is Cloud Clinic number 8. I'm Rob Fotland. I'm presenting here today, and this is the 8th in a series that we are um, presenting from the CloudBank program, which is a national NSF-supported collaboration between the University of Washington and UC San Diego and UC Berkeley. And the part of the CloudBank project that we at the University of Washington work on is education, outreach, and training. And so that's why we're doing this clinic here to sort of decompose the massive learning curve task of using the cloud for research computing into sort of more palatable bite-sized chunks. We hope that's the plan. And as always, if you have questions or want to get in touch with us over this material or other aspects of cloud computing, you can use help@cloudbank.org, and that's a ticketing system, so that should turn into a real human responding to you. This is me. That's what I look like, more or less, pretty much any given day. And I'm put this slide in here to emphasize that I am learning as I go. So I'm basically learning this stuff as a way of kind of being able to better support the cloud using community. And the cloud itself is not an end. It is, in my view, a means to an end. If you need resources and services that are available through a cloud platform such as Amazon Web Services or Microsoft Azure or Google Cloud Platform or something else, then that's what we're trying to support, is that learning process. And I'm coming to this not as a computer scientist, so my vocabulary tries to err on the side of being accessible. I do advocate open data science. That's an important part of the eScience Institute where we're located. And let's move on. So this is some I'd like to start off with to sort of contextualize the whole Cloud Clinic series. And as I mentioned, we try and create build paths that are not too gigantic to digest, but manageable. And we try and use GitHub to present this material and make it openly available. So the central challenge of using the cloud for research computing is that the cloud is really built for a team of developers to set up cyber infrastructure for a company. And whereas we are perhaps scientists and we are trying to build cyber infrastructure for doing research. And so there's some interesting crossover challenges built into that. So obviously we have the learning curves, but it's also very easy to spend $20 for some computing on the cloud when you could only be spending $1. And so we're trying to emphasize that efficiency is an important aspect of what we're learning to do. And then, of course, we want everything to be secure so that when we put our data out there or credentials to use cloud services that cost money, that's a safe thing to do. And that security bullet, that last bullet there, is really the underpinning for what I'm mostly talking about today. And today's discussion is going to be, it's listed here as Clinic 8, a cyber infrastructure exercise, and it's going to be part 1 of 2 because the task of building this out is proven to be very expansive. There's a lot of details, and so there's a bunch of stuff that we can talk about today as a sort of hopefully an introduction and an overview. There's a very anticlimactic demo, which may or may not work, to try and emphasize what we're doing here. But let me just run through quickly preemptible instances. We're Clinic 1. Those are this is called Spot Market, and it's a way of saving $7 out of $10 by using a particular resource on the cloud. We've talked about data publication and creating API access to data. We've talked about using Docker containers. That comes up today also. We've talked about connecting object storage to a laptop. That comes up today also. So this is sort of a synthesis of past topics. We've done a clinic on the Littlest Jupyter Hub, which is a good thing to know about, particularly if you're working with a small research team. We've talked about treating virtual machines as things that are reproducible. That's Clinic 6. And then we started to talk about artificial intelligence services on the cloud. And that's a big, huge part of what I'm going to be talking about today also. So that's the Cloud Clinic series. This is the same slide, but with links built in. So if you can follow the link to this slide deck, then you can get to that other content also. Okay, so that brings me to what I wanted to talk about today. Um, and that topic for Cloud Clinic 8 is cyber infrastructure build and some components to that process that I think are interesting. And the motivation for this comes from the typical beginner coming to the cloud and finding out that there's these virtual machines that are available and that there's vast amounts of data storage available, and there is plenty of networking capability available. So networking and compute and storage are the three basic resources or services on the cloud. And then there's hundreds and hundreds of other complicated things built on top of that also. Okay, so we get onto the console, which is a browser-based point of access to the cloud, and we log in, and then we go and we use a wizard to start up a virtual machine, and we sort of treat that virtual machine like it's something that's parked under our desk. And that's fine as far as it goes. It's often even completely adequate for a research project to simply work through the console. But at some point, we may end up finding we have more data to process than is conveniently done with just sort of one machine setup. And so then we start talking about pivoting to other ways of talking to the cloud. And there are two in particular that I will cite. One of them is using a command line interface. The AWS cloud is the one I'm going to be working with today, and the AWS command line interface is simply the command AWS. And then the second way of interacting with the cloud, sort of in a more programmatic way, is through Python using the Boto3 library and the command line interface, AWS. Both work in terms of an API, and that means that there's some underlying authentication going on. So that's what we're trying to do when we pivot from from the sort of getting a virtual machine to work and getting some code on it and some data on it to more of a manufacturing task of processing lots and lots of data. So to do this, we're going to introduce some second order technology beyond the browser-based interface. And I'm going to refer a lot to a coding assistant, which, as you know, we're becoming familiar with. People are coming in. Coding assistants are like Copilot and so forth, are a way of navigating the difficulties and complexities of building cyber infrastructure without spending a year of our lives going off and learning how to do it. So that's it. That's the general plan. This is not intended as a comprehensive guide to doing a lot of data processing. There's other technologies out there, for example, Dask, that are suited to parallel processing. But what we're going to be doing here is just using a toy example to motivate putting together some, like in a Tinker Toy sense, a bunch of different technologies. And those technologies are virtual machines, object storage, containerization, a development environment, integrated development environment, and then the coding assistant, as I mentioned. And these are respectively on AWS. A virtual machine is called an EC2 instance, and object storage is called an S3 bucket. And then we have the containerization that I'm using is on the Docker brand of container. And then I use VS Code as an integrated development environment. And then I use something called VS Code Server to extend that to an environment that runs on my cloud virtual machine. And then the coding assistant that I'm using is provided by Amazon Web Services. It's called QDeveloper. So a little middle bullet point here is that when working with a coding assistant, eventually it's going to make mistakes. And so I try and be on guard for that. And often I will ask the coding assistant to justify a step it's taking or to explain something to me so that I have a sense of following along and being confident in the direction that it's taking. But when it does make a mistake, then it's important to be ready to catch that and change direction and fix that. Um, and I have found in my brief experience with using coding assistants that if I do some sort of away from the chatbot interface, do some thinking about engineering the task, then I'm able to sort of operate in the introverted mode to plan something out. And that gives me a bias for working with the coding assistant as things move forward. And I don't have to hang on to that bias, but it sort of allows me to direct the progress of what's going on. So observations on CAs. And then recently, UW-IT Research Computing Group we presented a tutorial on Docker, and there's a link here to that. It's connected to the UW-IT Research Computing release of the Telecom GPU-powered supercomputer. And so there's a lot of different technologies here, and we're trying to cover them all and create artifacts that people can use to get started and feel confident that they're headed in the right direction. Okay, so containerization, since I keep referring to it, I'll emphasize two important aspects of it. One of them is that the containerization process has three stages. There's first a file called a Docker file when we're using Docker. And that Docker file lives in a project directory along with maybe some code and some other information. But that file, Docker file and the associated stuff, is converted into a Docker image. And an image is like a template for building a hermetic, self-contained computer. And an image can be used to launch as many of those sort of self-contained mini subcomputers called containers as one could want. And then I'll also mention that there is a duality challenge built into containerization because they operate as hermetic little computers that are running inside of a actual computer. But they also want to talk to the outside world so they can, for example, store their results. So there's something called a bind mount that allows a container to access the data of the host machine. Okay, so that's not so much disclaimers as just kind of an initial gloss on this stuff. And that brings us to this horrifyingly dense slide here, which on reflection, I think would be best broken out into some sub-slides. But if you'll just bear with me, I'm going to give you the narrative of what's going on here, and then we'll move on to just a few more slides in this presentation to sort of cover some of the details. So the toy problem here is simply to take, let's say, 10 data files and operate on them with a exclusive war kernel that's just going to flip the bits. So that's a very basic, simple operation. And the starting point for this, so that our plan is to sort of identify that we have 10, oh my gosh, 10 data files to process. And we want to process them in some kind of an automated way. We want to head towards the infrastructure that will support automated processing because tomorrow we might receive 20 more files, and the day after that we could receive 1,000 files. And so we want to start looking into ways of scaling up the cloud infrastructure. To put this another way, we tend to work in terms of a single computer and we kind of understand everything that's going on. But the cloud actually supports scale. So we're trying to bridge the gap between operating in a local host kind of way, whether the local host is a laptop or a desktop computer. And we're trying to go from that to taking advantage of the scale of the computing that's available in the cloud. So what's the first thing I would do in this journey? We would say, first of all, log into my laptop and install the Visual Studio Code development environment. And on that VS Code, I would install the QDeveloper coding assistant extension. So that allows me to bring up a chat window and ask all the, let's say, unsophisticated questions that I can possibly think of. And the Q developer will patiently attempt to provide explanations and answers to those questions. Okay, and then the next thing I do is go to a bash terminal and I will mount an S3 bucket. I've given the name of the bucket here, which is not a secure practice, but it'll be deleted. So who cares? The name of that bucket is CI for Cyber Infrastructure, and CC is Cloud Clinic. And that bucket name is unique, and I mount it using a utility called S3FS as a folder on my laptop. So I can look into that folder, and I'm actually looking into an S3 bucket on the Amazon Web Services cloud. And so I'll use that ability to look at that folder on my local laptop to spy on the activities of the other infrastructure. Okay, and then I write a Python script that's able to, it's called process.py, and it's going to execute our processing task, which is to take a data file and do an exclusive OR with the kernel to produce an output file. And there's 10 such files. And now we get to the, I guess that's the fifth bullet here, which is prepare an AWS account role for the VM to use. So I'd like to narrate this to restate that in English. We're going to be using a virtual machine to do our data processing. We're not going to be doing it on localhost. And that virtual machine is in turn going to be running a container. So when it does that, it's going to be operating against the data that's sitting on an S3 bucket. That's object storage bucket, S3 object storage service on the cloud. So both of those things are in the same cloud. And what the AWS cloud technology allows you to do is set up a role for one entity, in our case, the virtual machine, to access another service on the cloud. And so we're going to prepare that in advance so it's ready to go. And then in the next step, we launch a small, cheap virtual machine. And that virtual machine then takes on that role. And as it takes on that role, then it's able to do the processing that it wants to do. Okay, so now we've launched a small, cheap virtual machine. We now use the SSH, the secure shell, to connect to that virtual machine from the VS Code environment. We do this using something called VS Code Server. And normally I wouldn't think of belaboring this, but I actually showed VS Code Server to somebody who interned at X over the summer, and they're like, wow, that would have saved a lot of time if I'd known about that. So it seems to be a little detail that's definitely worth emphasizing. So now we're on a VS Code Server instance, logged into a virtual machine on the cloud. You see these terminology sort of piles up. And on that virtual machine, we're going to install Docker. That's in its native Linux format. And then we're going to install Boto 3, which allows our software to interact with the S3 buckets on AWS. And then we're going to set up a Docker project folder, which will contain a Docker file and some processing code. We're going to build a Docker image, and that again is on the virtual machine. And then we'll log into Docker Hub, which is a place where you can place images. And using my user ID, we'll push the image up there. And then we will set up a startup script that will run whenever this computer boots. And then again, this is on the virtual machine. We will simply run sudo reboot. So that's the demo that we have in store. And then we can look in on the S3 bucket and see if the data gets processed, but we can do that from localhost because the S3 bucket is mounted locally. Okay, so that's kind of the extent of what I have to describe today. And we're not going to actually go through these steps and, wait for everything to come together. This is sort of like the cooking show where the turkey's already cooked and in the oven, and you just pull it out. Um, but I do want to mention these side quests because this altogether ensemble will be sort of rolled up into the second installment of this Cloud Clinic, where we're going to talk about um, the whole thing as a flow. It'll be sort of like a representation of this stuff with extra stuff added with these side quests. So anyway, these are um, converting the virtual machine that I've been talking about into an Amazon machine image, which is sort of like it's sort of like a Docker image, but it covers the entirety, every last bit of what's going on inside the virtual machine. So that gets kind of hung on the wall as a bag of bits, and then you can use that to restart virtual machines. So again, as with containers, which are scalable by restarting multiple images, the same image as multiple containers, we can take an Amazon machine image and start multiple virtual machines. Okay. Um, I do not have it yet, but we will create a GitHub repository for all of the material that's in this presentation and in the next one. And I have to just make sure that I expunge any critical information from that. Let's see. Oh, actually, this already exists. The next side quest already exists, which is a test program. Sorry, so since we're going from an input file called, for example, in3.dat to an output file called out3.dat by using an XOR operator, if you reapply that same XOR kernel to the output, you'll recover back the input. So it's a simple way of testing that your code is working. Okay, so and this brings up the idea that the coding assistant isn't necessarily going to suggest building a test program, but once you have that idea in mind, it's good at writing those test programs. Let's see, another side quest is I mentioned Docker Hub, which is where we'll park the container, or sorry, the image that we're going to be running. So it's very illuminating to go on to Docker Hub and start looking around for public images that could be used. For example, there's a Mersenne Prime process GIMPs that you can find software to containers to just run. Okay, and then of course scaling up. So with that, that's a slog through a rather dense slide, but let's see what else we have here. Okay, so where is the data that we're processing? Here it is on my local directory. We have a folder called CICC/S3. If I say LS, it lists off 10 input data files and a kernel file and only 3 output files. So there's 7 more output files to be created. So this is sort of modeling a partially completed data processing task. But this is on my local computer, and if I say ls, it's actually on the Amazon S3 bucket, that will be reflected here because I'm actually going off to that bucket every time I say ls and finding out what's actually in it. So this is a little digression on this mounting an S3 bucket on localhost. And it's basically an infinite drive. And there's a couple of utilities out there. The ones I found are called Mount S3 and S3FS. And S3FS is slower, but it's more similar to a POSIX file system. And Mount S3 is faster. It's owned and operated by Amazon, by AWS, and it's a little bit less full featured. Okay, I think I've pretty much said everything on that slide. Okay, so now I mentioned that we're running a container, and that container is created so that it can execute a Python program called process.py. And it's executing data XOR with a kernel to create to produce the output file. And so this is kind of probably the most technical and but also essential piece of this presentation is understanding what happens when that container runs that Python program. because the container is not trying to mount the S3 bucket locally and operate on the files that way. Instead, what the container is doing is it's reaching into the guts of the S3 bucket and looking at what's there and grabbing some data from there and pulling it into its own memory, operating on that with the kernel, and then writing an output file back to directly to S3. And this is Python code, so it's using the BOTO3, BOTO3 Python library to interact with the S3 bucket. Okay, let's see. So this is primarily to run a Python script, which in turn uses BOTO3, but one does not simply walk into AWS and start reading objects in S3 buckets. They're secure. So you need to have some kind of an authentication in order to do that. And so how is it that a container is able to just walk in and start working with S3 data, S3 bucket data? So there's a missing detail, which is I hit it on that massive text slide. The missing detail is that the host EC2 instance is configured to assume something called a role. And that role in turn contains a policy. So I'll try and explain it that a role is like having a name tag holder with a lanyard that you wear around your neck. And you can put on the role, but it doesn't mean anything. There's nothing in that name tag holder. But a policy is actually sort of code that describes your name and your permission level. And so together, the role with the policy act as a badge that gets you access to services on AWS. So that's the thing that we put together. And it says here, I'll just read this. So the gory detail is the EC2, that's an Amazon virtual machine, is given an instance profile wrapper, which I'm not going to belabor. But the point is that this thing that it's given contains a role on AWS that includes permission. It's okay for you to talk to this particular S3 bucket. And what's nice about this is that when we use the original way of interacting with the cloud by going into the console and zooming around and using wizards and stuff like that, what we tend to do is we tend to sort of click on this button that says, give me an access key. And then that access key ends up floating around on our computer, and it's maybe copied into a virtual machine or copied into a container or something like that. It's very high risk, poor security practice. But what we're doing in this case is we're creating this thing called an instance profile that takes on a role that has a policy that allows us to do what we want to do. But we're doing this all within the AWS cloud using a much more secure mechanism. And so this is permission to work with S3 buckets that's done without leaving any kind of super powerful artifacts lying around in case there's some kind of a security breach. This is much, much safer. So that's the sort of description of a new person's description of how things fit together and allow our container running on a virtual machine on the cloud to access S3 data and process it. Okay, so I mentioned several times the coding assistant called QDeveloper. That's AWS's coding assistant. They're rebranding that to become, they don't call it Cairo, they call it Kiro. So there's always a moving target as to how you keep up with this stuff. But the nice thing about QDeveloper is that it knows about Amazon, the Amazon cloud. And so it can come up with code and commands like bash commands to execute command line interface tasks that amount to the stuff that we're describing here. And I've already mentioned that QDeveloper is great at writing test programs and so forth. The test program I had it write was called xorinversion.py, and I ran it, and it confirmed that the inversion process worked. Okay, I've mentioned VS Code Server, and so I just want to point out that in the very lower left corner of the VS Code application, there's this funny little greater than, less than symbol. And if you click on that, you get a menu that allows you to specify a remote uh, host, and then we'll connect to that with a new window. And so then you'll suddenly feel like, oops, you'll feel like you're running VS Code on the cloud virtual machine. Yeah, it communicates using SSH. Okay. And then I think this is the last sort of mechanistic slide that I've got. This is what the Docker file looks like that we're using to create the Docker image, and then hence the Docker container that will do the processing. And the anatomy of Docker files is fairly straightforward. It first of all selects a base image, which is a modestly small version of Python, and that comes along with Debian Linux for the ride so that you have that operating system available. And then it's traditional to work out of a directory called APP. And the next line is obviously going to install the Boto3 library for use by the process.py code, which needs to be copied to the app folder. So that's the next line. And then it makes that process.py file executable, and then it finally just runs this Python process.py command. So that plus the actual process.py code is all that is sitting in the build folder for the Docker image. And then here's an example of what I found extremely useful for using a coding assistant. So I typed in a prompt. I noticed there are two images. This is when I'm on my virtual machine on the cloud, and I'm building the image that I'm going to put on Docker Hub. So I notice there's two images. One is called CICC processor and another called Python. Is it okay to delete the Python image? Because I figured it wasn't being used. And the coding assistant says, don't delete the Python image. It's the base image from which my actual processing image is built from. And if I delete it, then everything will still work, but it'll have to be like burning more resources down the road when I rebuild it. So I think this is a pretty strong statement on strong evidence for the utility of the coding assistant. Okay, and then this is I mentioned that we gave a Docker workshop some time back. So at this point, I think read that later. And I think we'll skip that. So this is my conclusion, but before I do this, let me just bring up a couple of windows for a second and see if we can run a quick demonstration. So if I'm sharing the screen, then this should be visible. And all I'm going to do here is notice that I'm in the S3 folder on my laptop. And if I list the contents of the files here, I notice that I have 10 input files in 0 through in 9, and I only have 3 output files, out 0, out 1, and out 2. Okay, so I've processed 3 of my 10 input files into output files. And then I keep talking about VS Code Server, and that's the second window that I've just brought up here, and I'm sure that it's not easy to see what's going on here, so I'm going to make the text a little bit larger. Okay, so hopefully that's more visible. So where am I in this in the universe? I'm at the home directory for a user named Ubuntu on a cloud virtual machine. If I say ls, I can see there's a Docker development file. That's where I put my Docker file and my process.py code. And then that's what's used to build a Docker image, which I then push to Docker Hub. Then I also have a startup-script.sh, and that's the script that's going to run on this computer when it reboots. And so let's see if that's legible. Yeah, so this the startup script is fairly short, but you can see down at the bottom it runs Docker, it runs a Docker image as a container 4 times. And it does so well, and whenever every time a container finishes, it deletes itself. That's the dash dash RM. So this is a script that will run if I start this computer up, but the computer is already started up, so the script's not going to run. But it's going to run the Docker processing task 4 times. So all I have to do is to say sudo reboot. And remembering that in the black screen, that's a local host of my laptop terminal, I can see there's only 3 output files, out0, out1, and out2. So if I say sudo reboot, drum roll, please. This is now telling a cloud virtual machine to shut down. So since I'm attached to it, I suddenly lose my bash prompt. And what's going to happen is it's going to go down and it's going to come back up again. And it's going to, so VS Code Server, that's what this window is here. It says cannot reconnect. So I'm going to reload the window. Now I'm going to come back over to my local laptop and say ls-al. And now out3, dat, and out4, and out5, and out6 all exist here. So that is a successful demonstration, albeit anticlimactic, that my virtual machine on the AWS cloud is in fact running a startup script that fires off 4 consecutive container runs that produce 4 output files from my input file collection. So that's like I say, it's anticlimactic, but it did work. So that's good. Okay, so that's everything that I wanted to present. It looks like it took me a typical 30, 35 minutes. My conclusions are that the coding assistant is super interesting development in the world, and it's something that can enable us to switch from using wizards and sharing access keys and basically low security behavior on the cloud to this role-based access control, which is much more secure and doesn't involve leaving credentials out and committing them to GitHub and having bots find them and mine Bitcoin and so forth. So the sub-bullet for the coding assistant thing is we don't know what we don't know, by which I mean that I can't ask questions about something to a coding assistant on something that I don't know about already. So I have to have a clue, and that's why this kind of collective learning that we're doing and consulting with one another is an important part of the process for me. And part 1 of the Cloud Clinic cyber infrastructure example has been this sketch, and part 2 will include a side quests and so forth. So on behalf of, so to speak, CloudBank and UW eScience and UW IT Research Computing, that's everything I had to present today. So thank you so much for your attention.